Hi U10s. In this video I'm going to go through some of these other graphs that we haven't quite seen yet, and also moving the graphs of hyperbolas left to right with transformations. Okay, so I'm going to go through how to use a calculator along the way, and hopefully you can link this with the transformations task that you did earlier this term. So what we're going to do is, first of all, you can see here there's graphs of 2 to the x minus 3 and 2 to the x minus 4 as a power. And all of these things affect the graph. And before we do that, let's go to your CAS calculator, and I'll open that up. And what we'll do is we're going to go through some of these. So let's, for example, start with this one here. These are hyperbolas, but these are hyperbolas that have had transformations to them. So now we've just been recently looking at the graph of 1 over x. Okay, and 1 over x is this thing. You can see that there's an asymptote here. Never touches the x-axis. There's an asymptote here. If I was to add another one though, and we're looking at this one here, let's look at this one here. Let's put in 1 over x plus 2. Okay, so let's go and do that. So let's put in our fraction, and let's go 1 over x plus 2. What do we notice? Well, let's look at this key point here. That's actually moved to the left, and it's moved across. Well, it looks to me that point there, 1, negative 1, negative 1, has moved to negative 3, negative 1. So it's actually moved to the left too. Everything has moved to the left too. Notice here this asymptote that's here has now moved to the left too. Okay, we've still got an asymptote here because everything, if I move that to the left, it's still going, it's never going to reach the y equals 0. It's never going to reach that point. And likewise, if I was to do the other one, we've got 1 over x minus 6. Let's have a look at what that does. Okay, so you should really be practicing with your CAS calculator throughout these exercises as well. Well, we've actually moved everything. Let's have a look. Let's zoom out a bit. We've actually moved this graph here, this blue one, 1 on x. We've actually moved everything down 6, which means now we have an asymptote at negative 6. And as you can see, everything has moved down 6. This point here has moved down 6. This point here has moved down 6. Everything has moved down 6. Okay? So let's have a look at some of these. So we're going to familiarize ourselves with these transformations and be able to describe them as well. So the graph of 2 to the x minus 3, I've actually got that here. So you can see that if I... let's pick a point. Let's pick a point 1. Let's pick a point which would be, so let's put this point here. Well, that point here, let's do this one here. This point here, you can see 2 to the x minus 3 has been, every point has moved down 3. If I was to go here, every point here has been moved down 3. So the translation is that we're translating the graph of 2 to the power of x down 3 units. Over here, though, this 2 to the power of x minus 4, you can see that this is this graph here, the green one. And what we've done is we've actually moved every point to the right 4. So you sort of, I guess what we've 2 to the power, that's like saying 2 to the power of x minus h. Okay, and that is basically moving at h units to the right. Okay, so think about just like your quadratic. Okay, for quadratic you'd have a x minus h squared plus k, and then your turning point would be at hk. So it's actually moved at h units to the right and k units. If this was x plus something though, like if it was something like that, then we've actually moved that 1 unit to the left. Okay, so that's the tricky one. in sort of the opposite sign, the opposite direction to what you think. Okay, so this one has moved everything to the right 4. This point here has been moved to the right 4 units. Okay, so this translation of the graph to the power of x, let's call it right by 4 units. And this one over here, well, as we sort of said before and I showed you on the calculator, that has moved that left by 2 units. And this one here has moved it down. Okay, so we sort of see a consistent thing throughout. So now this also applies to other graphs. For example, here's a graph of a circle, and a circle is in this form, x minus h all squared. So if you see something like this, and also we've got here like the radius. Okay, now HK is the center, so a circle actually starts off in the center and then it's moved. So it starts off here, and as you can see for this graph here, we've moved the center to the right one. So we just look at the center first, and we've also moved it down one. So this graph here would actually have the form. We know that it's going to look like this. It's going to look like x minus 1 all squared. Notice here this k, it's not over here, okay? The center is actually at negative. So we've got to look at that opposite sign. So we're looking at y, this would be a graph of y plus 1 squared is equal to, what's this radius? Well, the radius, let's go and have a look at what the radius is. So let's have a look. The radius there, we can go, that's 1, 2, 3 units. So if the radius is 3 units, then of course what we've got to do is we have to go ahead and square it. So if you have something that looks like this, that's going to be a circle. Okay, so they're the first ones we're looking at. We're going to look at circles, but once again, this whole H and K applies to all of these graphs, not just one of them. So once you sort of get that pattern, you'll sort of start to see that for other graphs. Okay, so now look, let's start with a circle. Okay, now I've got this up here, and you can see here I've just put that HK is the center of the circle. So let's find the center of the circle. It says sketch the graph, including important features. So we're talking about, what are we talking about? Well, we don't have asymptotes on a circle. We've got X-Intercepts. We've got Y-Intercepts. They're the important features that we need. And also, I guess, the center of the circle. Okay, which we can get straight from the equation. Okay, so let's first of all, let's have a look at this. Let's work out what the center of the circle is. That's always a good point to start when doing these. So the center is at HK, but it's in this form of x minus h all squared, y minus k. So the center, what would this have to be? What would x have to be for this to be 0? X would have to be equal to 2. And what would y have to be for this to be 0? Y would have to equal minus 3. In other words, it's really just the opposite sign. So the center is therefore at the coordinate 2, negative 3. Now let's go ahead and mark that on the graph. Let's go, okay, let's call that 1, 2, 3, and so on. Okay, minus 1, minus 2, minus 3. So let's go 2, negative 3. Let's go, okay, 1, 2, 3. So I want to actually put my center of the circle there. Okay? So now, of course, we've got a radius of 3. So we know that let's draw the edges of the circle. If it's a radius of 3, it's sort of going to come out to here. But we also know that if it's got a radius of 3, then the edge of the circle is sort of going to be there. It's sort of going to be out here somewhere where 5 is. And our circle is going to look, and we'll go down another 3, let's say there. And this is what our circle's going to look like. It's going to look something like this. Just knowing that it has a radius of 3. Well, how do we know that? Well, this thing is, according to our rule over here, is r squared. So, of course, the radius is not 9. The radius is 3, since 3 squared is 9. Now that's what our graph's going to look like, but now let's go ahead and find what our X and our Y intercepts are. I'm doing it by hand. Okay, so the X-Intercept with that Y equals 0, the common theme that we've been doing for everything. And let's go sub that in. We've got X minus 2 squared plus, well, Y is 0, so it's 0 plus 3 squared. And that's equal to 9 now. X minus 2 squared, let's just write that. 3 squared is 9, so we've got plus 9 is equal to 9. Subtract the 9 from both sides. We've got X minus 2 squared is equal to 0. Well, what would X have to be in here for this to be 0? Well, X would have to equal 2, wouldn't it? The long way of doing it would be take the square root of both sides. Okay, so take the square root of both sides. Square root of 0 is just 0 though. When I do that, there's only one solution. That's X minus 2 is equal to 0. And add 2 to both sides, X is equal to 2. Okay, now as you can see, there you go. There's my X-intercept. It actually just touches the X-axis. So here's my intercept at 2, 0. And there's only one place it touches. Sometimes there's 2. Now, of course, there's actually going to be one, it looks to me as there's going to be 2 Y-intercepts. How do we find the Y-intercepts? Well, we're going to have to let X equal 0. Okay, so let's go ahead and do that. Let's sub it into the equation. 0 minus 2 squared plus we need to find the answer to this. Now this time, now minus 2 squared is positive 4. Let's subtract 4 from both sides, which gives us Y plus 3 squared is equal to 9 take 4 is 5. Take the square root of both sides, but this time when I'm taking the square root of a number which isn't 0, then what we have is I've got Y plus 3 is equal to, well, there's 2 solutions. Okay, there's 2 solutions. There's plus or minus the square root of 5. Okay, so you see here, you need to get 2 solutions. That's the hint that we're going to need to find both the positive and minus square root. Let's subtract 3 from both sides. So we're looking at Y is equal to minus 3 plus or minus root 5. Now, what is that like realistically? Well, the square root of 4 is like 2, so it's going to be a little bit more than 2, but it's not going to be as high as 3 because we know that the square root of 9 is 3. So you can see here that we're looking at minus 3, that's going to be roughly, approximately plus or minus, 2 point something, which means that if I was to add 2 point something to negative 3, we're still got this negative answer. But you're perfectly fine to leave this as an exact answer. So for example, this point here that I'm referring to, this point here, is going to be, well, let's call that would be the bigger of the two. That would be minus 3 plus root 5. Okay, and this one over here would be minus 3. That would be Y equals minus 3 minus root 5. Like so. They're all the important points. We've got the center, we've got the radius. We can see that if we do the radius, then it actually, we can almost find the X-intercept that way, and then we can find our Y-intercept. We've got a Y-intercept here and a Y-intercept down here somewhere. Okay, now what I'd like you to do is try this now. I'm going to pause it. I'll get you to pause it, and I'd like you to try this question. See if you can do it. See if you can find the X-intercepts, the Y-intercepts, the center of the circle, and the radius. Have a go. Okay, so what you can see now is you can see that I have done the working for this. Now, just quickly, when you see this, I guess technically it's in the form of X minus H all squared. If I was to write it like this, like a double negative, you can see there that this H in this case is negative 1. Okay, so it's this value here, negative 1, and here is negative 2. So whenever you have these positive ones, I guess this is technically why it's the why my center is a -1 and a -2. Okay, so the center is, or you could like think about it, what do I have to do for this to be equal to 0? X would have to be -1. X would have to be -2, and the radius squared, this thing is the radius squared. It's not the radius, it's the radius squared. So the radius is 3. Now, what you do is, once you find the center, which is -1, -2, you can see there that I've marked it out here. Now, once I mark it out here, then it's nice to mark that center out, and then mark 3 points to the right and 3 points right and up and down. Mark out where that center goes, because then what we can do is we can draw a try to draw a nice looking circle. Not easy to do though. Now, of course, we've got to find those key features. Well, the X-intercept is when y equals 0. When I go ahead and throw that in, then what we have to do is I have to subtract 4 from both sides, gives us 5. When I take the square root, though, I've got the positive and a negative value. Okay, so let's leave it as this. This is -1 plus or minus √5. So let's label this as coordinates. This would be -1 plus √5, comma 0. There's my x1. We've got another one though. It's -1 minus √5, comma 0. And our y coordinates, well, I've got over here, by letting x equal 0 and solving. You'll need to fill this out and try to do it this way, please. This is -2 plus √8. We could simplify that, but for not necessary for now. And this is -2 minus √8. There's all my key features. Doesn't look quite nice because it's not whole numbers or anything, but that is how we do our circles. And like I said, the algebra for probably sketching circles is probably the harder of the few, because the algebra often you will get square roots and things. All right, so now we're going to be looking at these other graphs. So we're looking at exponentials in your transformation task. We're moving it left to right. Notice this H and K again. Here's H, here's my H, and here's my K. So we're translating H units to the right in this case. If H was if I had something like, if I had the graph of 2 to the power of x minus 3, then that would move that 3 units right. Okay, the easier one is this one, because that just moves it up or down depending on it being positive or negative. We also have an asymptote as well, which moves up or down. All right, now let's have a look at this one. Well, first of all, it'd probably be nice to sketch the graph of 2 to the power of x and see what that looks like. If I graph 2 to the power of x in a calculator, let's do that. Well, what are we going to do? If I go to 2 to the power of x, let's try that. 2 to the power of x. There you go. It looks something like this. We've got this asymptote, sort of approaches it, but it never gets to this point. It's it never gets to x equals to y equals 0. If I go ahead and add another graph, then let's do this 2 to the power of x plus 2. 2 to the power of, you'll need to practice this, x plus 2. And then we're going to press across, and then we're going to subtract 3. Well, what that does is it's moved this graph, it's moved everything on this graph. It's moved it left 2 units and down 2. I think actually it's down 3. So let me just try that again. All right, let's try that again. 2 to the power of x plus 2, and then it was minus 3, not minus 2. Okay, so it's moved everything to the left 2, and it's also moved it down 3. So that's what it's going to look like. Now, that includes the asymptote that was there. So the asymptote now has has actually, with these graphs, is instead of being here at y equals 0, that's one of those key parts of the graph that has now moved down. It has now moved down 3. 1, 2, let's call that 3. Okay, so now that's probably the first thing to do. If you move the asymptote, then you're going to get the shape of the graph right. Y equals -3. It's going to get there, but it's never going to quite reach. Okay, so now that we've got that, let's go ahead and sketch our graph. Okay, let's do, first of all, what we're going to do is, I'm going to just say that the X-Intercepts, we're not really going to, it's beyond the scope of this course. We are just going to find using the CAS. Okay, we can find the Y-Intercept okay. Let's find the Y-Intercept though. The Y-Intercept, we let X equal 0. So let's go ahead and if I was to let X equal 0, that's 2 to the power of 0 plus 2. Well, 2 to the power of 2 is 4. 4 take 3 is 1. Okay, so what we have is the the Y-intercept is at 1. Let's call it there. And our graph is still going to have the same shape. And by the way, I have no problem with you using your calculator when doing this. Here's my graph. This is my graph of 2 to the x. 2 to the power of x plus 2 minus 3. Now, if I was to compare that with, say, a graph of 2 to the power of x, well, 2 to the power of x is actually sort of going to look something like this. Probably it's going to be the same sort of steepness as this other graph, but it's actually moved, everything has been moved to the left 2 and down 3. Okay, so this point here has been moved to the left 2 and down 3. Everything has been moved to the left 2 and down 3. Use your CAS calculator though. If you do that in your CAS, it'll be your best friend. Now, of course, the X-Intercept though, we're not going to use any method to show you how to do that this year. But what you'll need to do is we can go Windows and we can analyze the graph, and we can find, if you wanted to, we could find where it's 0. We could look for this one, we can look left and right. Well, we can get some decimal approximate of that. But I'm not too concerned about the X-Intercept for the time being. That'll be for next year in Year 11 methods for those of you doing that. All right. I know that this is a fair bit to do. Let's. Can I get you to try this one here, please? Now, if you can do it, great. Pause it, give it a go. If you can't, well, I'll go through it in a second. All right, you can see here that this graph here, well, first of all, the X-Intercept I'm not too phased about. There's no real way we can, based on what we've shown you, to find the X-Intercept other than use your calculator. The Y-Intercept, we let x equals 0. Let's sub that in. 2 to the power of 0 take 1. Well, what is 2 to the power of -1? Well, it is the same as 1 over 2 to the power of 1. That using our index laws, and 1 over 2 to the power of 1 is like a half. A half take 1 is -1/2. So the things that we just need on these graphs are, we just want the Y-intercept, and also notice that this has moved this graph 1 down. So usually on an exponential graph, we have an asymptote at y equals 0, but you can see there that this asymptote has been moved 1 down. So whenever you sketch these graphs, you'll need to sketch the asymptote. If you do it in the CAS calculator, it won't show you an asymptote. It won't show you this horizontal line which it never touches. So we do need, that is a key feature, this asymptote, this part here. All right. Now, we've just done hyperbolas in the previous exercise, but this time we're moving them left and right, up and down. As you can see here, usually we have an asymptote here at x equals 0. and we usually have one at y equals 0. Well, this time what we're doing is we're moving this asymptote to the right 2 units, okay, so 2 units to the right. So where those asymptotes meet, that's actually where the transformations that have taken place. We've moved it 2 units to the right, and we moved it 1 unit up. Okay, so that's where this sort of thing here, this H and K comes from. It's starting to repeat itself. The asymptotes now, therefore, are moved as well as according to this. Okay, so these asymptotes will be required now, where a lot of the time you just had the X and the Y axis. So let's go ahead and try this now. First of all, let's look at, in English, what's happening to this graph. First of all, look up here, X minus H, so it's moved 1 unit, not to the right, it's moved 1 unit to the left, okay? So that's X minus H. If I have over here X minus H plus K, okay, so that's going to be, in this case, that's going to be X minus 1, if you like. That's my H value. Okay, so let's move that -1 units, or 1 unit to the left. So that means that the asymptotes here, instead of it, I'm going to just make that's now X is equal to -1. We've moved the asymptote, and likewise, this has moved it 2 units up. So instead of having 1, let's go here, 1, 2, I've now got Y is equal to 2. You can see they're doing that. You draw the asymptotes. It's going to give you a pretty good idea. Now, the graph of 1 on X is sort of something that looks like this. It's sort of that rectangular hyperbola. Still going to have the same shape, but it's moved to the left, right, up, down. Now, of course, you probably should find the X and the Y-intercepts first, but you can see there that I guess if I have something like that, it's going to look something like that. Let's go ahead and find what those intercepts are. So the X-intercept is when we let Y equal 0. Let's go ahead and find that. 0 is equal to this. Let's find it. Well, let's get the 2 on the other side. That would make sense. Okay, and let's do a little swapsy. If I had two fractions like this, I could sort of move everything over there like so. It's sort of cross multiplying. Let's replace the X plus 1 with the -2. Okay, so what we've got is we've got X plus 1 is equal to, well, let's just 1 over -2. All right, and well, that's just like -1/2, isn't it? And then I get the 1 on the other side. You can see there that X is equal to -1. We'll call that -1/2, which of course is like, we'll call it -1.5, like so. So there you go. Now what we've got, here's my X coordinate, X-intercept. That's -1.5, 0. And now I guess what we can do is, does it cross the y-axis? Well, yes, it does. It crosses the y-axis there. So the y-intercept is when X equals 0. This one's a bit easier though, because you can see there that we've got this 0 plus 1 plus 2. Well, 1 divided by 1 is just 1, isn't it? And 1 plus 2 is 3. So that y-intercept there is this guy here, which was pretty close to where we just guessed, wasn't it? 1, 2, 3. It wasn't too far off. It's actually just going to be, I think it was up here. Okay, so it's going to come down here, and it's going to come down there a bit more, like so. But it wasn't too bad a guess. All right, so that means that now we have found all of the features of this graph. We've found the X-intercept, we've found the Y-intercept. Importantly, from the graph, we need to know that it's because it's moved to the left 1 unit and to the right and up 2. That means that usually where these two asymptotes meet here, they have been moved. Well, so it's the left 1, so that's been moved to the left 1, and it's been moved up 2. Okay, so now this is where the center is. That's where you should draw your asymptotes, and please label them. Okay, label them quite clearly. These asymptotes here. Here's x equals -1. Here's y equals -2. You got the correct shape. You can use the CAS calculator for the correct shape if you're having problems, and also then go ahead and find the rest. Now, I know that that's a lot. Now, before we finish up this video, I want you to see if you can do this one. I'm going to pause this. I'll get you to pause it now and try it. I'll go through the solution in a second. Okay, so look, now you can see there that I have done my working for this one. First step, you should need to recognize it's 1 unit to the right and it's 2 units down. So that means that these asymptotes meet, well, we've got to move everything to the right 1 unit. Okay, so that means that this asymptote here is at x equals 1 now, not x equals 0. The y is likewise, that's been moved down to. So instead, it's now at y equals -. So get the asymptotes in the right place. Then, of course, it makes it life much easier. You can sketch the graph, and I guess you've just then got to find the key points. I'll pause that. You can pause that and finish that off. I know that that's a lot in a lesson, but once you really sort of immerse yourself into this, you start to see that all these transformations are really the same sort of thing, the same idea for every graph. If you look at it in isolation, you think, gee, how am I going to remember all this? Well, really, the same theme applies to exponential graphs, to hyperbolas, to even to circles. It's all moved left and right, up and down with dilations and things. It's not as bad. So once you start making those connections, hopefully that it gets easier and easier. If you're going to go into methods, this is the first unit, graphs of all of these. Gallery of graphs, it's called, your first unit. So you're going to need to familiarize yourself with this, particularly if you're going on to do methods. I'll leave you to it. All the best. Good luck. There's a lot to take in one video. I get that. But you do need to practice it. And if you don't practice, you really are going to be behind the 8 ball. Okay, thanks for your attendance. I'll see you in class.